vous propose d'enchaîner avec la troisième et dernière présentation de l'après-midi avant de passer au débat. Donc, ce sera David Kanter qui nous rejoint donc de New York University, qui va nous parler donc de la réglementation du cycle de l'azote et des pollutions azotées. Et donc David Kanter a terminé un séjour en France il n'y a pas très longtemps, à Sciences Po notamment. Il a fait un petit passage au LIEP et il est aussi donc président de International Nitrogen Initiative, donc une association scientifique sur le sujet. Je te passe la parole pour une demi-heure.
Merci beaucoup. Bonjour à toutes et à tous. Je m'excuse en avance, en fait je vais présenter en anglais parce que même si je parle un peu français, je préfère dans un cadre professionnel ou académique de présenter mes recherches en anglais. Je ne suis pas aussi habitué que Petros de présenter dans ma langue secondaire. So that's the extent of my French. I'm going to go to the inferior language of English now. I apologize. Petros and Alia have set me up wonderfully by setting up the kind of the historical and scientific context of this, and now we're going to kind of shift to the governance challenge of how we address what is emerged as one of the most important environmental problems of the 21st century, that is, and at the heart is one of the central challenges facing humanity, which is, can we feed the world and save the world? Can we supply enough nitrogen and phosphorus and other essential nutrients to supply enough food to feed a growing population, while also not exacerbating the many environmental and human health problems that nitrogen pollution makes worse? Okay, and I'm going to start actually with a video because part of my séjour here for the last year and a half was working with the Clinique de Droit, the law clinic at Sciences Po, where we were working on trying to develop new policy propositions to address the algue verte problem. And my students, completely of their own motivation, directed and developed a video, a short animation, 3 minutes, that is going to summarize this 30-minute talk much better than I will be able to do. I haven't managed to connect to the sound of the room. It'll be coming out of my laptop, but it is quite loud, and most importantly, the images are nice. So, and it's just 3 minutes, so if it doesn't work, it doesn't work. But so, attends, on va essayer. I'm going to turn it around so hopefully that you can hear the sound of it better. I'm going to do this.
Salut, nous c'est Olivia, Dylan et Gemily. On est étudiants en droit et en politique de l'environnement à Sciences Po. Cette année, on mène un projet avec David, un professeur de l'Université de New York qui est spécialiste des pollutions azotées d'origine agricole. Ensemble, on s'intéresse au cas particulier de la Bretagne, où ces pollutions sont rendues visibles par la prolifération d'algues vertes. Aujourd'hui, on a besoin de vous pour nous aider à porter un message important. On vous explique tout dans cette vidéo. Mais d'abord, c'est quoi au juste ces pollutions azotées? Le lisier ou le fumier issu de l'élevage, ça vous parle? Eh bien, ils sont très chargés en azote, un élément essentiel pour la croissance des plantes et pour la vie tout court. Les agriculteurs en épandent donc sur leurs champs, sous forme d'engrais naturels ou de synthèse. Si tout l'azote épandu était absorbé par les plantes, alors il n'y aurait pas de problème. Mais en fait, il faut savoir qu'environ 50% de l'azote épandu est perdu dans l'environnement et contribue à le polluer. Cette dernière décennie, on a donc complètement bouleversé le cycle naturel de l'azote. Et pourtant, c'est un sujet dont on parle peu, alors qu'il est fondamental. Dès lors, par rapport à ce qu'on vient de vous dire, quand on veut limiter les pollutions azotées, on peut penser à réguler les pratiques des agriculteurs en premier lieu, non? Mais pourtant, attention, cette intuition omet le fait que le système agroalimentaire comprend de nombreux autres acteurs, comme les producteurs de fertilisants, les abattoirs, les distributeurs comme votre supermarché du coin ou encore les consommateurs. En plus, on observe que dans le système agroalimentaire, il y a des pertes directes d'azote à toutes les étapes. Alors, vous vous demandez sans doute quel levier nous, on a identifié pour agir efficacement. Eh bien, c'est celui de l'influence que ces acteurs ont sur les agriculteurs, à travers justement leur fourniture d'engrais, leurs contrats commerciaux, financiers ou encore tous leurs canaux de communication informels. Par exemple, on pourrait encourager les producteurs de fertilisants à commercialiser des engrais de synthèse plus propres et respectueux de l'environnement. Ainsi, face aux pertes d'azote et aux enjeux de santé publique et d'environnement qu'elles soulèvent, comme c'est le cas en Bretagne avec les algues vertes, nous, on se dit qu'on devrait s'intéresser à réglementer tous ces autres acteurs, et qu'ainsi, on pourrait avoir nettement plus d'impact qu'une réglementation visant les agriculteurs eux seuls directement. Pour porter notre message, en ce moment même, on participe à la concertation citoyenne du 7e programme d'action régionale nitrate sur les algues vertes, et on a besoin de vous. Ce qu'on propose, c'est de s'intéresser à tous les acteurs en interaction avec les agriculteurs, qui ne se limitent d'ailleurs pas aux acteurs de la chaîne agroalimentaire qu'on vient de vous évoquer, mais qui incluent aussi les banques, les assurances, les syndicats, les coopératives, les stations d'épuration et bien d'autres. Par exemple, les syndicats pourraient promouvoir des sessions pédagogiques à destination des actuels et des futurs exploitants pour déployer des pratiques d'épandage plus efficaces et plus écologiques. Alors, si vous aussi, vous pensez qu'il faut élargir la focale et penser le système dans son ensemble pour agir, apportez votre soutien à notre proposition. Pour en savoir plus, rendez-vous sur le site de la concertation citoyenne. Votez pour nous!
Voilà, so that was actually part of, as you said, as they mentioned, a concertation citoyenne, where there were over 250 comments on this 7e plan d'action sur le régional du nitrate. This one, our proposal got the most votes, and we were involved in several policy discussions on this, and it was really fascinating. I'll talk a bit more about this at the end. But my central points today are going to be, and I'm inclusive. I don't just think about nitrogen, I think about phosphorus as well, which is also a very important nutrient, and that also has a really important environmental impact, notably on the water side of things. They're both essential to life, and they're important threats to the environment and human health. But, and this we've already heard about, but what is frustrating from a policy perspective is that most policies, when they're trying to address pollution from agriculture, and about 2/3 of nitrogen and phosphorus pollution come from agriculture, they traditionally focus on changing farmer behavior. How can we get farmers to use fertilizer or manure more efficiently, right? And they've had pretty much, I mean, they've been in some small cases, some successes, but mostly ineffective around the world. And I'll explain and get into why, or at least my theory of why, and a project that I've been working on now for the past couple of years, including my time in Paris, which is a project called Governing Nutrient Pollution Beyond Farmers, which is this idea of creating a new governance framework, targeting other actors in the système agroalimentaire, as you saw in the video, across the food system to ultimately influence what happens on the farm. We'll look briefly at this case study of the Sciences Po Law Clinic on the algues vertes, and I'll briefly talk about the next steps in this project myself. One figure that wasn't shown, so I kept this in my slides, but I do think it's important, is the planetary boundaries figure. I'm sure many of you have seen this figure before. It's probably one of the more iconic figures in environmental science over the past 10, 15 years, right? And each wedge in this pie of environmental catastrophe is a specific environmental issue, right? So you have climate change at 12 o'clock, you have ocean acidification at 5 o'clock, you have land system change at 9 to 10 o'clock. And the aim for humanity, right, is that we want to stay within the safe green zone. And that as we get further and further out, first to the yellow, there's a zone of uncertainty, and then to the red, where there is relative certainty that we have surpassed a planetary boundary. That means that our level as a species, humanity, our level of interaction with that specific environmental issue has gone beyond a safe operating space, where the damage increases exponentially and potentially permanently. The most intuitive boundary that everyone knows, or everyone in this space knows, is the 1.52 degree target for climate. That is considered a planetary boundary for climate, right? And according to these scientists, there are only 2 boundaries at the moment that we have surpassed. More recently, they're thinking about a third in regards to plastics, but at least here, there are 2 boundaries. The first is biosphere integrity, which is essentially biodiversity loss, the number of species. The species extinction rate today is 1,000 times greater than natural rates of extinction. And then nitrogen and phosphorus, right? And this figure is really what brought nitrogen pollution into the mainstream from a policy perspective. And what it is saying here is that the amount of nitrogen that we are fixing every year, mainly through the Haber-Bosch process, but also through a biological nitrogen fixation, through soybeans, and also through the use of manure and animal production, is way beyond what the Earth system can actually absorb and take every year. Okay? Now, I'll fast forward a bit and think about, okay, so we have this pollution, and one thing that this figure does not show you, because no one figure can explain every single thing, but what this figure does not show you is the interactions between these different planetary boundaries, right? They seem like individual environmental problems. And that's fine, and it's a useful communication and educational tool. But what's unique about nitrogen is that it makes every single one of these problems worse, okay? Because nitrogen compounds such as nitrous oxide is the third most important greenhouse gas and the largest remaining threat to the ozone layer. Both of those make climate and ozone worse. Nitrates, as we talked about, is the key contributor to the algues vertes problem in Britain, right? So freshwater use over here. It is also a huge impact on biodiversity because as there's more nitrogen in the system, it favors plants and animals that like a lot of nitrogen, right? And so it disrupts the natural kind of biodiversity equilibrium of a specific ecosystem. So nitrogen makes all of these problems worse. Now we have measures to improve nitrogen use efficiency, as was talked about in the last two talks. I'm going to vastly oversimplify the kind of two main strategies for doing it, which is how we apply and what we apply. The how we apply is changing either the techniques and technologies with which we apply nitrogen or the practices that we use, right? So this is a graphic showing, for example, GPS technology, satellite technology, that allows farmers to understand what parts of their farm need more nitrogen than others, and then they program that into their tractors, and that allows them to differentiate or be more precise in their application of nitrogen. So they're not actually changing the formulation of the nitrogen, they're simply improving the efficiency with which they are applying nitrogen. It's part of a whole class of techniques known as precision agriculture, right? And then there's the whole what we apply, right? So here it's really about the technology of the fertilizer itself. Again, the nitrogen is not changing, that stays at the core of the fertilizer granule. But here, for example, you have these fertilizer granules that are coated with a polymer that dissolves over the course of the growing season. It delays the release of the nitrogen in the soil, and it better synchronizes nitrogen demand and supply in the soil. Just a little caveat here that I will say, which is that a lot of these measures that we talk about to try and improve nitrogen use efficiency take as their assumption that the best that we can hope for and what we should be aiming for is to optimize the current system of production, right? We have this industrial agricultural system, and that what we should do in the whole, even behind the word efficiency, is to make the current system of production more efficient, right? And so what that doesn't necessarily allow for is transformation, right? And so I just want to make that clear that there are also other measures here that could be more transformative, right? Beyond simply efficiency measures, whether it be changes in diet, whether it be changes in how we produce meat in a lab or alternative meat proteins, whether it be about the work that Alia was talking about, making plants that currently are not leguminous into legumes. So there are a lot of measures that already exist to improve nitrogen use efficiency, but in most parts of the world, farmers are not using them, right? I could show you many different surveys and things. It's actually very difficult. If someone has data on this in the European perspective, I would love to see it. I've tried for a couple of days to find it, and I can't. But the rate of farmer adoption of nitrogen best management practices, right? This is just to give you a sense, just one specific example, one specific study. This is in Michigan in the United States, where they asked them about one specific technology that delays the release of nitrogen in the soil. And it's emblematic of many other nitrogen management practices, right? Where over 60% say they never used that particular technology, then about 15% say they experimented with its use, and then there's a very small portion that either use it regularly or sometimes. Okay? And most importantly, what we care about, and the kind of the most damning indictment of our lack of capacity to deal with this problem, is ultimately that the pollution, nitrogen pollution, continues to either increase or remain stubbornly stable. just to give you a couple of examples, this is the area of the dead zone, of the hypoxic zone in the Gulf of Mexico, right? So under Texas and kind of with Mexico there is a dead zone there every year the size of Jamaica, roughly. And not Jamaica, Queens in New York, but the country Jamaica. Okay? And the goal, there is a hypoxia task force. It's this governance program that attempts to limit the size of that hypoxic area to, this is in miles. We all know that miles aren't a real thing. It's square kilometers. And square kilometers, they want to limit it to 5,000 square kilometers, right? That's the dashed line here. And this is instead the size that it's been every year within the 5-year average. And you can see it's vastly beyond the goal. Even though this hypoxic task force was created in the late 90s, you can see that there's been really no progress towards reducing the size of the hypoxic zone. The only years where we've come close to limiting the size of the hypoxic zone is not because there's been a sudden kind of come to Jesus moment that all farmers have decided to reduce their amount of fertilizer supplied. It's because there's been drought. And so there's been less runoff into the Mississippi River, which is what leads into the Gulf of Mexico and creates those hypoxic zones. Similarly, in Europe, pollution levels remain stubbornly high. Here you have the percentage of waters not in good ecological status or potential, and many parts of Europe, in fact the majority of Europe I would say, where the majority of water bodies are not in good ecological status, and a big part of that is high levels of nitrate pollution. Now, at the same time that we have these not particularly good environmental trends, we're having increasingly ambitious environmental targets, policy targets, right, that are emerging. So, for example, in Europe, famously, we have the farm to fork strategy. 4 pillars of that strategy linked to pesticides and antimicrobials and the transition to organic farming. And a big part of it is nutrient losses. They want to reduce nutrient losses by 50% by 2030. That is hugely ambitious, right? And in tandem with that, to reduce fertilizer use by 20% without sacrificing food production. Okay? This idea of halving nutrient losses came from the Colombo Declaration on Sustainable Natural Management in 2019, which was inspired by a small workshop we organized at NYU in January 2018, where we came up with this target of halving nitrogen waste, and that made its way into the Colombo Declaration. I don't know if it then directly translated to the farm to fork strategy or they came up with it themselves, but I'm going to say that they took inspiration from us. Most recently, the post-2020 Global Biodiversity Framework, this the Kunming-Montreal Framework on Biodiversity that was agreed in December this past year. They have a number of targets related to biodiversity. The most famous one is we want to set aside 30% of the surface of the earth for nature by 2030. Target number 7 is to reduce nutrient losses by 50% and also reduce pesticide risk by 50%, right? And then, and Ali, I was talking about this too in terms of the Russia's invasion of Ukraine and the spike in fertilizer prices that created, there is suddenly quite a bit of interest from big players like the US government in how can we develop more efficient fertilizer technologies. They raised $135 million because that's what the US does. They don't really regulate things, they just throw money at things sometimes. And from a European perspective, right, this is an annual report, it's called the Environmental Barometer Report from the Institute for European Environmental Policy, where they look at the progress made on a bunch of European environmental priorities and the level of priority that they have. This is in a survey of environmental experts around Europe, right? And we can see a healthy food system for people and planet is one of the top priorities for many of these experts, but is one where there's been the least progress made, right? So that speaks to the fact, so there's this real tension when we have these ambitious policy targets, and yet we're not making nearly enough progress on the kind of scientific, actually measuring, when we measure indicators of environmental health, and when it comes to policy, right? And that's because, again, to oversimplifying things, regulating farmers is very hard. And it's very hard for a number of reasons. Not all of which I will list here, but just to list a few. One, obviously, food security is an important national priority for many countries. Nitrogen is unique in this way. I got my start in environmental research looking at the Montreal Protocol, right, that banned CFCs and spray cans and air conditioners to save the ozone layer. And it was a relatively easy policy policy proposal because you could simply ban CFCs. You could replace them with alternatives. You can even imagine a global energy system that bans CO2. If we transition completely to renewables, and I know we're in France, so let's say we have a big role for nuclear as well, right? That's an energy system with close to zero CO2. We cannot imagine, as Petros and Alia pointed out, we cannot have a global food system without nitrogen. Nitrogen is life. You cannot ban nitrogen, right? And food security is obviously a key national priority for many countries, especially countries that are still emerging economies. So food security is an important national priority, and the moment you start talking about increasing nitrogen use efficiency, some people hear that as you want to reduce fertilizer use, you essentially want to put people back into extreme hunger and not allow us to develop. Second, from a kind of implementation and enforcement side of things from policy, that nitrogen pollution, and especially from agriculture, is what we call a non-point source pollutant or a diffuse pollutant. It's not like a power plant, right? I don't know the numbers in Europe, but in the United States, for example, there are about 1,000 or so coal power plants left in the United States, right? There's about 900 million acres, so what is that, about 400 million hectares of agricultural land. So trying to enforce regulations over that large amount of land versus on, say, 1,000 power plants, right, is very difficult. It's spread over 2 million farms, right? And so enforcing policy over such a large land area when it's spread across and the pollution doesn't come from specific sources is very, very difficult. And then finally, and this is where my own work comes in, which is that the focus of most policy to try and address agricultural nitrogen pollution is focused on how can we get farmers to manage nitrogen better, right? Whether we can tax fertilizer or incentivize certain programs. And it ignores the fact, and this is something that, for example, rural sociologists have known for a long time, but that farmers are actually very constrained in their decision-making, right? That these policies regulating farmer decision-making kind of assume or project a certain level of autonomy. Not a certain level, a lot of autonomy onto farmers. And of course, there is a lot of autonomy that farmers have in terms of exactly what they do at the field level, but there's also a lot of constraints that influence why farmers do what they do, right? And those constraints can be classified into a number of different buckets. They can be regulatory constraints, where you have rules either from government or private sector or legal liability, rules that constrain farmers or mandate them or prohibit them or incentivize them to do certain things, to use nutrients in certain ways. There are market constraints, right? The prices of products or prices of inputs, labeling and certification requirements, production contracts, the contracts that farmers enter into with their suppliers or with their syndicats or with big supermarkets, and changing consumer preferences. You have social constraints, right? The networks that farmers find themselves in influence what farmers think is feasible and what is considered good agricultural practice. Knowledge constraints, especially the drive towards consolidation in agriculture, has steered farmers towards a more narrow range of what is considered conventional practice. And then farm constraints. The size of a farm influences economies of scale, how much farmers can invest in new technologies that allow them to be more nitrogen efficient. And also, if you're renting the land versus owning the land, right? And I don't know what the rates are. Again, Europe, I apologize. I know in the States, in certain states, up to 60-70% of farmers in any one state rent their land. You have a much shorter time horizon. You're focusing on maximizing your yield, or much more likely focusing on maximizing your yield and not on sustaining the land over the long term. You have a much shorter time horizon. So where are these constraints coming from? Well, they're coming from forces beyond the farm and actors beyond the farm, right? I'm not going to go through this whole system. I didn't make this figure myself. It's complicated, and that's the point, right? That farmers are here, and then there are all these other actors and forces that are influencing why they do what they do. And if you look at successful environmental policy in the past, it finds the right leverage points, which means it doesn't necessarily focus on where you would think that it would focus. For example, going back to the Montreal Protocol, instead of focusing on consumers and people buying refrigerators, saying we're going to ban consumers from buying refrigerators with CFCs, they said, no, we're not going to focus on consumers, we're going to focus on the producers. We're going to say the production of CFC is banned. And guess what? That was much easier because there were a few hundred factories around the world producing CFCs. Similarly, with the Stockholm Convention, which regulates pesticides like DDT, for example, and other harmful chemicals, instead of regulating farmers, they regulated pesticide companies and said, you cannot produce these chemicals anymore. Fuel efficiency standards for cars, which we find around the world, most of those standards, instead of trying to regulate how people drive, I know in Paris there are certain days people, I don't know if that's still a thing, but anyway, the point is that most of these fuel efficiency standards instead focus on regulating the car companies and saying you have to make your cars more fuel efficient over time, giving consumers no choice but when they purchase a new vehicle, if they purchase a new vehicle, that car will be more fuel efficient. So that gets me, with 30 seconds left in my presentation, to the governance framework that I'm focusing on, which is this, I'm calling governing nutrient pollution beyond farmers. The central question being, how can we reduce agricultural nutrient pollution beyond just regulating farmers, which seems to be how we've done it for most of the past few decades that we've been trying to address this problem. So the objective is to try and design a new governance framework focused on these non-farmer actors in the agri-food system that can influence farm-level nutrient management, and you turn a non-point source problem into a series of point source problems. And I'm happy in the Q&A, the debate afterwards, to talk about specific examples. There are 3 components to this project. The first is understanding the agri-food system from a nutrient perspective. So really trying to understand, well, what are these forces that influence farmer nutrient management decisions? Design new governance interventions with these law clinics like the Clinique de Droit à Sciences Po. And then having designed those new interventions, then trying to create transition pathways and also policy mixes, because there is no one policy that is a silver bullet, right? And so trying to find the best coherent combination of different policy mixes. And this is the basis also of a ERC project that's currently under evaluation. And so these 3 components, as I said, the kind of systems mapping. So this is an early draft of a systems map that we had in the United States, of doing a similar project and then trying to adapt this in a European context. Developing these new governance interventions, so specifically focusing on non-farmer actors, right? So to give you a specific example here, farm advisors, right? Farm advisors are often one of the most important sources of not the most important source of information to farmers, right? They're the people that often sell farmers the inputs and advise them how to use them, how much to buy, what to do. So regulating those actors or figuring out ways to change the incentives facing those actors, right? So the incentives to provide fertilizer services in addition to fertilizer products. Here with the Loi Egalim in France, focused on pesticides, there was a specific provision there that tried to address this conflict of interest, where many farm advisors not just sell pesticide, but also advise farmers on how to use that pesticide. And the Loi Egalim said, we're going to separate those 2 things. You either choose to sell pesticide or you choose to advise farmers how to use that pesticide. You can't do both at the same time, okay? And then developing these transition pathways and policy mixes. And I'm happy to go into this in more detail. I'm just conscious of time. Very briefly, I'll talk about the Sciences Po Law Clinic. We have this Brittany case study, and inspired by, I'm sure many of you know, this Algue Verte graphic novel. It's amazing, just as a side note, everyone I've spoken to, in fact, from my family, my wife's family is from Brittany, and everyone obviously knows this story. Everyone I speak to knows this. Everyone recommends this graphic novel. The amount of awareness of Algue Verte and nutrient pollution in France compared to anywhere else I've been is very astonishing. And so they wrote this 60-page report, this independent report, outlining 9 new policy propositions. If you just Google Sciences Po Algue Verte, you can find it. There was a webinar where a bunch of journalists and policy folks, we met with the various préfets and stuff that in Brittany that were focused on this. And they did all this design themselves. They, outlined the systems approach to addressing the Algue Verte. Well, that was the kind of framework that I gave them, but then they showed that this is the whole système agroalimentaire, or at least part of it in Brittany. And the point being that most of policy just focuses at the farm level here and trying to regulate the farm. And each number here is this new policy proposition that they came up with, focusing on other actors in the système agroalimentaire. And the little flags, I don't know if you can see it, I'm sorry, the resolution isn't very good. The little flags refer to at what échelle, at what scale they intervene. So where you see the French flag at the French level, here is the Brittany flag, you have the European flag here, right? So you have Chambre d'Agriculture, you have the Banque and Assurance, right? So you have all these different actors, right? And they have a range of different proposals, which I won't get into now. I'll perhaps use just one example where mobiliser le bien-être animal comme levier. This was actually inspired by what's happening in Germany, which is a coalition government between the socialists and the Greens. and the Greens control the Ministry of Agriculture, and there the Minister of Agriculture decided that one way to get at the environmental impacts of animal production and animal agriculture was not to go at it from an environmental perspective, but to go at it from an animal welfare perspective, and say, well, because there seems to be a majority of the public that is in favor of improving animal welfare. And a big part of improving animal welfare is reducing the density of livestock operations. And if you reduce the density of livestock operations, you're also reducing the amount of manure that can be produced, you're reducing the amount of nutrients that can be lost to the environment. And so then you have to find the right economic instruments that can compensate farmers for that reduction in production. And there was a lot of reaction to it in West of France and in all these other publications that I had never heard of, including Port Mag. Is apparently a thing I did not know, but I now have a subscription. And so just to give you a sense of the next steps, so we have this ERC proposal focused on expanding the focus of this project to the EU as a legislative scale, but then specifically also the Netherlands and Spain. The Netherlands obviously has a massive nitrogen problem. They have the only minister for nitrogen. In the US, we have a couple of manuscripts in prep describing this framework and also proposals out there. This is just recapping the central points. And I will just end by saying, as Martin mentioned, I'm the chair of the International Nitrogen Initiative. We have a webinar this Friday, Halving Nitrogen Waste, which is kind of organized around this idea of these emerging policy targets, organized around this idea of halving nitrogen waste, including we have some of the policy folks that were involved in kind of formulating those ideas that will be speaking. That'll be on Friday from 2 to 3:30 Paris time. And so you can register, and I can send you details if you're interested. Thank you very much. I look forward to the discussion.
Le point le plus proche de New York.
Oui, comme vous savez, New York is a center of agricultural production. I live in downtown Manhattan, and that is really the hub. Yeah. Well, Washington Square, there are so many things growing and being smoked and everything. It's great.
As we said, the banks are part of the system.
Yeah, exactly.
Je pose la question en français.
Oui.
Est-ce que votre équipe a fait des enquêtes auprès des agriculteurs bretons concernés par, qui travaillent en amont des algues vertes? Est-ce qu'il y a eu des enquêtes?
Did we interview farmers?
Oui.
Yes, so we spent a week in Brittany, but we interviewed probably about 30 different stakeholders, from policy people, but we interviewed several farmers that were both on all sides of the spectrum, farmers that like organic farmers, but also farmers that had been very much resistant to any kind of increased regulation, farmers that were leading the charge. And like with anything in life, it's nuanced, right? There are many different actors, and there are many, and there are very human stories on all sides. But one thing that was clear across all of them is that they are in many ways reacting to the broader system that they are a part of, right? That they are doing what the system incentivizes them to do. And the system incentivizes them to maximize production, right? And so if there was a shift in the priorities of that system, they would be open to it, but they don't want to be the people that are the only actors that are targeted, right? Which makes sense. We need to, so that's the idea behind this project, is that to just focus on farmers ignores the broader forces that are driving farmers to do what they do, or a lot of farmers to do what they do. I don't know if that gets at your question.
You propose to have an action on the producers of nitrogen fertilizers rather than the farmers, but maybe I didn't. What do you propose?
So, well, the action there would be, and I have a few slides on it, but we actually took inspiration from the fuel efficiency standards for cars, right? Where the idea for fuel efficiency standards for cars, as I mentioned, was that instead of regulating drivers, you're giving drivers no choice but to use more fuel efficient cars. We asked ourselves, what would that look like for fertilizer? Well, you either mandate that fertilizer products have to reach a certain level of nitrogen use efficiency in the soil. So these new polymers that are being developed, right? They are currently in like the first generation of production, and they work well in some areas but not in other areas. They work well in some climates and crops but not others. And to have, this is one important role for governments, is to kind of force innovation in an otherwise very conservative sector. Right? The fertilizer industry is very conservative when it comes to the amount of money that it spends on R&D. And so forcing them to spend more of that money, to innovate more in R&D, would be a way to do that. So that's the idea of regulating the fertilizer companies. In addition, again, no one of these proposals would be to substitute or be like the one silver bullet, but it's meant to show that there is a much broader range of policy approaches that could be used to address this problem beyond simply just let's stop farmers from doing X or Y or Z.
But there are also buying startups that are preparing bio-based stimulants. The big firms,
Yes.
they buy startups which develop the microbial biofertilizers.
Yes. So some, I
So
mean,
it's
some of them are.
It fits with what you say.
Yes, and some of them are, and those first movers will be rewarded, hopefully, right? That the idea is that they would, and then others are betting on the fact that we will still be using nitrogen fertilizer for the next 100 years, and they don't need to, innovate. Right? Nitrogen is nitrogen, and so there, in some ways, it makes sense that we don't innovate because plants will always take up nitrogen. You don't need to make it more. It's the building block of life. It's kind of like coal in a way. You just burn it, you're going to get energy. And so when you compare that to pesticides or GMOs, where the system requires you to innovate, with nitrogen you don't really need to. And so that's where, at least in my view, the role of government can be very important in forcing innovation, in forcing a shift in what would otherwise be kind of the market equilibrium.
Peut-être tu peux vous pouvez faire installer là, comme ça continue la conversation.